Hi, fourth grade. Welcome to today's Eureka math lesson. Today we're going to be covering lesson 2, module 6. Use metric measurement and area models to represent tenths as fractions greater than 1 and as decimal numbers. We know that fractions can represent a value that is less than 1, but we can also use fractions to represent a value that is more than 1. And we are going to talk again today about how we can also represent those values using decimals instead of fractions. Excuse me. We're going to do all that using metric measurements. Let's get started right away today with the application problem. Please open up your blue Learn books, the module 6 and 7 Learn book, to page 7, please. That's the lesson 2 application problem. That page looks like this. Yesterday, Ben's bamboo plant grew 5/10 of a centimeter. Today, it grew another 8/10 of a centimeter. How many centimeters did Ben's bamboo plant grow in 2 days? Let's use our cubes strategy to highlight and underline the important information in this word problem. Let's break it apart. First, let's circle the important numbers that I see here, okay? We're working with 5/10 of a centimeter. I also see 8/10 of a centimeter. The word grew tells me that these values are increasing. When something grows, it gets bigger, right? Pardon me. If Ben's plant was being chopped down or trimmed, maybe it would be decreasing. Grew means it is increasing, okay? We need to underline the question. What's the question? What are we trying to answer? How many centimeters did Ben's bamboo plant grow in 2 days? Circle, underline, box. Do we need to eliminate any information? In this problem, I don't think so. Okay, and now we can solve. Let's use a tape diagram to draw this problem and represent it visually. Okay, don't forget that in addition to cubes, we can also use the RDW strategy to read, draw, and write to solve this problem. Okay, we already read the problem. R, done. Let's draw it. A tape diagram is a good way to represent these two known values and how they can be combined to create our unknown value that we're trying to find. Okay? Nice and neat. We've got a whole page here, so give yourself a lot of room to draw your tape diagram and separate it into 2 different sections to represent our 2 values. I like to be as accurate as possible. We have 8/10 and 5/10, and we know that 8/10 is a little bit more than 5/10. So I'm going to draw my line so that one side of my tape diagram is slightly bigger than the other. We have our 2 values, 8/10 of a centimeter and 5/10 of a centimeter. Okay, take a second to make your paper look like mine. I know I write fast. Don't forget you can pause me now, okay? Everybody's dream come true. You can finally pause Mr. Hansen. We have our value of, we have our unknown value of the amount the plant grew in the 2 days, okay? It grew 8/10 of a centimeter. That's today, right? Today's G for growth. And yesterday it grew 5/10 of a centimeter. That's yesterday. G for growth. 5/10 and 8/10 combined gives us our total growth for the 2 days. When we have an unknown, we should really be representing that with a variable, right? A letter. Since it's Ben's bamboo plant, B for Ben, B for bamboo. Okay, this tape diagram is a picture that represents the growth of Ben's plant. This is the D in our RDW strategy. Read, draw, write. We read, we drew. We're going to start to write the equation that's represented by this problem. This tape diagram shows us that 8/10 plus 5/10 equals something, right? A value that we're going to find right now. Let's represent this with an addition sentence. Eight tenths plus 5/10 equals 13/10. Remember that when we are adding fractions with like denominators, that the denominator actually stays the same. Tenths are the unit that we're adding, okay? They could just be represented also by apples or pencils, right? Instead of 8 pencils, we have 8/10. And instead of 5 pencils, we have 5/10. 8/10 plus 5/10 equals 13/10. The same way 8 pencils plus 5 pencils would equal 13 pencils. So our total value for the growth of Ben's plant in the 2 days is 13/10 of a centimeter, right? But 13/10 of a centimeter is not the most complete way to represent a fraction, right? If the numerator is bigger than the denominator, that's called an improper fraction, and that means the fraction is a value that is greater than 1. So we can represent this fraction not as 13/10, but as 1 and 3/10, because 10/10 is equal to 1. So we can remove 10/10 from 13/10, convert 10/10 to 1 whole, right? Because 10/10 and 1 whole are equivalent. And 13/10 of a centimeter becomes 1 and 3/10 of a centimeter is the total growth for Ben's plant in 2 days. That's the value B, right? From our equation here, from our diagram here, B equals 1 and 3/10 of a centimeter. Our last step is to write this answer as a complete sentence. What is the value, 1 and 3/10 centimeters? It is the amount Ben's bamboo plant grew in 2 days. So at the bottom here, Ben's bamboo plant grew 1 and 3/10 of a centimeter in 2 days. Application problem complete. Right process complete. If you have any questions about that, make a note, okay? And we can talk about it later when we meet separately. Let's take a look at a centimeter ruler and mark 2 centimeters on the ruler. If you're from 202, you should have a ruler in with your stuff. You might have to check inside some of your books. I stuck it in there like a bookmark. If you can't find it, then you're just going to have to listen and follow along, because all we're going to do is make an exact diagram of 2 centimeters. Hold your ruler with the centimeter side up and mark 2 centimeters. Start at 0 at the edge of the ruler and stop at the 2. If you're doing this without the ruler, then you just need to draw a short line on your paper so that it looks like mine. We're going to extend the line 6/10 of a centimeter between 1 centimeter and 2 centimeter, and between 2 centimeters and 3 centimeters. Each centimeter is divided into tenths. Each line represents 1/10 of a centimeter. And right now we're going to extend our line 6/10 of a centimeter from the 2 to 6 lines after the 2. Mark with a line 2, 0, and mark the end where we stopped. So we have a line that looks like that. What this line tells us is really an addition sentence. 2 centimeters, which is represented from here to here, plus 6/10 of a centimeter equals 2 and 6/10 centimeters. Make sure your paper looks like mine. I'm going to give you a second to copy that down. You can show the same value using decimals instead of fractions. So instead of 2 centimeters plus 6/10 of a centimeter, we would write 2 centimeters plus 6/10 of a centimeter. It's the same value, and it's pronounced and spoken the same way, 6/10 of a centimeter. Together, that equals 2 and 6/10 of a centimeter, or to say it quickly, 2.6 centimeters. Let's do the same thing again with different numbers. Move down to a separate spot on your paper, give yourself some room, and let's draw 3 5/10 centimeters using our centimeter ruler. Again, if you don't have one, please just draw a short line on your paper. Three and 5/10 centimeters. Mark out 3 whole centimeters. The value that's represented from the 0 in our ruler to the 3 is 3 centimeters. And this value that's shown here is 5/10 of a centimeter. That can be represented with a fraction or a decimal. 5/10 of a centimeter. What this diagram really shows us is just like a tape diagram. It shows us that 3 centimeters plus 5/10 of a centimeter equals 3 5/10 centimeters. So as an addition sentence, that would look like this. 3 centimeters plus 5/10 of a centimeter equals 3 5/10 of a centimeter. Bonus points if you recognize, and we'll talk about this more later, that this can also be called 3 1/2 centimeters. We'll talk more about that. But if 0.5 is 5/10, we should remember that 5/10 represents 1/2. If we look just at the 1 centimeter section of our ruler, the distance between 0, which is represented by the edge of the ruler, and 1, we can see that there are 10 tenths in between 0 and 1. 1 centimeter is made up of 10 tenths. So if I add another centimeter, two centimeters, I no longer have 10 tenths. I now have 20 tenths. 10 tenths in 1 centimeter plus 10 tenths in the second centimeter equals 20 tenths. If I reveal 6 tenths more, I now have how many tenths? That's right. I have 26 tenths. 10 tenths plus 10 tenths plus 6 tenths. Write that on your paper now. In fraction form, 10 tenths plus 10 tenths plus 6 tenths equals 26 tenths. But don't forget, we're talking about measurements. We're using a unit. We're using centimeters. So what this really looks like is 10 tenths centimeters plus 10 tenths centimeters. Your paper should be looking like mine. Plus 6 tenths centimeters equals 26 tenths centimeters. Okay, 10 tenths plus 10 tenths plus 6 tenths equals 26 tenths. Let's show that same value with a tens chart. 1/10 area model. 10 tenths of a centimeter plus 10 tenths of a centimeter. How do you shade 10 tenths? Carefully shade all 10 columns in your model. Each of these squares has 10 columns. Don't scribble it or make a mess out of it. Just diagonally shade the way we learned quickly. Each full model represents 10 tenths of a centimeter. Okay, our number sentence is 10 tenths plus 10 tenths plus 6 tenths. So for your last model, only shade in 6 columns. This model gives us a picture for the number sentence that we just drew. 10 tenths. Your paper should look just like mine. This model is in your Learn book. It is page 13. 10 tenths plus 10 tenths plus 6 tenths. 26 tenths of a centimeter. Don't forget your labels, like I almost did. Now let's represent it with decimals. 10 tenths plus 10 tenths plus 6 tenths is 1. Written as a decimal, be 1.0. plus 1.0 plus 0.6. So we read that as 1 plus 1 plus 6/10 equals 2 and 6/10. And again, let's not forget our labels. Centimeters. Make sure your paper looks just like mine. Again, this is page 13 in your workbook. Okay, let's take out our Blue Learn books. Turn to page 9 in your Blue Learn book, please. You should be on the lesson 2 problem set. We are in, what do you call it, module 6, lesson 2. Okay, I'm going to go over a couple of problems in the problem set. After I go over some of each, you're going to complete them by yourself. Then you're going to complete the exit ticket. I'm going to show you exactly how to do the exit ticket problems in this problem set. It's the exact same type of problem. Okay, look at number 1. For each length given below, draw a line segment to match and express each measurement as an equivalent mixed number. 2 and 6/10 is how you read this. 2 wholes and 6/10 of 1 whole. Written as a mixed number. Remember, a mixed number is just a whole number and a fraction together. 2 and 6/10. You say it the same way, 2 and 6/10. That's all you have to do for this part. When it says as an equivalent mixed number, that sounds confusing. All they want you to do is write it as a fraction. Show a line segment to match. If you have your ruler, use your ruler to draw 2 and 6/10 of a centimeter. If you cannot find that ruler, draw a line segment, label it 2 centimeters. It won't be exactly 2 centimeters, but that's okay. Then draw a shorter line segment and label it 6/10 of a centimeter. This line segment matches this information here. Okay, and you can label it as 6/10 of a centimeter, or you can label it as 6/10 of a centimeter. The important thing to know is that both these values are the same, one written as a fraction, one written as a decimal. 2 and 6/10. Don't forget your labels, like Mr. Hansen keeps doing. Number 2 is another problem that you're going to see on your exit ticket. Write the following as equivalent decimals and then model and rename the numbers as shown below. 2 1s and 6/10 written as a decimal. What do you know? It's the same exact value from up here. 2 1s and 6/10. Showing it as a decimal here, it is 2 and 6/10. To show that value in a tenths model, you're going to entirely shade 2 whole models neatly with diagonal lines, shade 10 out of 10 columns in each of 2 models, and then shade 6 out of 10 in the 3rd model. We're showing 2 wholes and 6/10 of a whole. That is exactly the same as the work that you're going to be doing on your exit ticket. Shading to represent values that are more than 1, and drawing a line segment and labeling it. look back to the problem set, finish the problem set first, complete the exit ticket, and submit. That is it for lesson 2. Get in touch with Mr. Hansen if you have any questions. Message me. If not, we'll see you soon.